All right, here is a challenging homework problem. Number 6 has a pentagon base, and you see how they drew this over here. This is the height. See how they're trying to show you that the top base isn't right over the top of the bottom. It's called oblique when it goes at an angle like that. So they've got them kind of shifted off from each other, and it's going at an angle like that, which is not that big of a deal. This is kind of easy that they tell us the height. I'm glad they do that. We don't have to use Pythagorean theorem or something fancy. It tells me the base edge is 3.5, so I'm going to put 3.5 there, and this requires us to draw in a couple radii, right? So this process, we've done this a few times, and then we draw the apothem in here. Well, why are we going to need all that? Because this is the base, and the base is a pentagon, regular pentagon, so we're going to use 1/2 apothem times the perimeter. Oh, what would the perimeter be? 3.5, 3.5. So that's 5, 3.5. So if you take that times 5, it's going to give us what? 25 to 15, 17 and a half, right? So the perimeter, this is how you do the perimeter, is going to go, let's see, it's 1/2 apothem times the perimeter. So I'm going to put the 17.5 right over here. Now, the apothem might be a little tricky here. This piece, let's highlight that in red. This piece is going to be 1.75, because it's half of 3.5. Okay, let me just say that again, half of 3.5. I think that's 1.75, right? The other piece of information we're going to need in this triangle is an angle. So there's a couple different ways we can do that. We could say 360 divided by 5. 360 divided by 5 is 72. See, that means this angle right here is 72 degrees, and I'm dividing by 5 because we'd have a radius going over there, a radius going up there, a radius going over that one. So we'd have 1, 2, 3, 4, and then 5. We're dividing 360 by 5 to get that central angle. That means that this angle right here is 36 degrees. Well, this is the opposite leg, and the apothem is the adjacent leg to that 36-degree angle, okay? So I could go like this. To get the apothem, I could say the tangent of 36 degrees is equal to 1.75 all over the apothem. Or I could find this angle right in here. Let's see, these are the two acute angles in a right triangle. So I've already used up 90 right here. There's 90 left between these two. So this angle is 54. These always have to be complementary, the acute angles in a right triangle. So 36 and 54 make 90, right? So I've definitely got 54 there. I could do this. Tangent of 54 degrees is equal to the opposite leg over the adjacent leg, 1.75. Now, why might this one be better? Because on this one, the second option, all I have to do is multiply by 1.75, and the 1.75s are going to divide out here, and I multiply by 1.75 on this side, and this thing right here should be my apothem. So I'm going to take this guy, and I'm going to see if I can squeeze it in this little tiny space right there. 1.75 tangent 54. Tangent 54. Oh, man. So now we're going to jump over to Desmos. Let me open up Desmos while you look at that, and you put that down in your notes. And I open up my calculator. I'll drag it over onto the screen. You can see in just a second, okay? I have 1.75. So I'm typing this stuff into Desmos right now. 1.75 tangent of 54 degrees, and making sure I go over to degree mode. So I'm switching to degree mode right now. Let me drag this over. This would be a good time for us to start looking at this. So see how I went and I made sure I'm in degree mode by clicking on the little wrench tool and going to degree mode. I got 1.75 tangent 54. Let's jump back over to our problem. So I've done this part. That's that part right there. I need a half, and then I'm going to multiply by 17.5. So I need a half somewhere. So let's put that right out here. 1 divided by 2. We'll put the apothem in parentheses. Not that we absolutely need to, but we'll do it anyways. And then let's see what else we got. Oh, so 1/2 apothem times perimeter, 17.5. So we need to put 17.5 right in here. 17.5. Where did that 17.5 come from again? That was the perimeter of the base, right? 3.5, 3.5. So there were 5 3.5s, 25 to 50. Yeah, 17.5. Okay, we got that. What else do we need? That's the area of the base. Now we multiply by the height. My goodness, I need to multiply by 9, and it should be 189.7. So let's put all this down. So volume is the area of the base times the height. Well, the area of the base is all of this stuff right up here. Let's see, I'm gonna put a blue bubble around this stuff right here. So it's all of this. That's our base. That is going to go right there. Okay, so we're gonna have our base, and then we're gonna have the height, which was 9. Okay, now all of this is on Desmos. Let me show you that. Okay, so 1/2 perimeter times apothem. I'm doing apothem times perimeter, I guess. This is the apothem and the perimeter. Then there's my 9 part. So, man, I hope that's clear. I'm going to take the 9 off for just a second. I'm going to put a decimal approximation down. So I'm on Desmos. I'm going to take the 9 off, and I'm going to put down 21.1 just so that people can see a number right here. Okay, so this is 21.1. But now it's an approximation. And if I use 21.1, let me just double check I got that right, 21.1. If I use that times 9, I could be off by more than is allowable in the tenths place. So notice what I do. I can write on my paper, but I've definitely put times 9 right here. And then 189.7 is my approximation, 189.7. Okay, now let's check something out. If I go 21.1 times 9, 21.1 times 9, I get 189.9. Oh, look at that. If you took 189.9 and put that into McGraw-Hill, it would count you wrong because it's supposed to be a 7. Do you see that? We're off by more than that's allowable. Thanks for watching that problem. This is going to be challenging, but I know you can do tough stuff. So work at it. Ask me questions. Thank you.